Good morning, children.
Good morning, children.
Let me know in the comment section that Wa alaikum assalam, MD Mudassir. Yes, I'll be taking on YouTube because it is easy. So let me know if my voice is audible and the screen is also clearly visible, whatever I'm writing on the screen. Good morning, Jack too. I don't think there will be any problem because I've connected to high quality mic, so noise reduction is also there here. Yes. Okay, so let's wait for 1 minute because there are only 30 students who have joined. Your class strength is 80, so at least 50 is better. Walaikum assalam. Okay, yes. Yeah. So let's begin the session. Okay, there are 62 now. No, this is perfectly fine. So I know everybody is hearing, so you can start the session, right? So this was, yeah, that was second year. Okay. So I'll be taking a session for around half an hour. I think that's enough. Yeah. Good morning, all of you, and assalamu alaikum, all of you. Right. So we were talking in yesterday's class about linear momentum. So we were talking about linear momentum. So linear momentum is indicated with the symbol p bar, which is mass into velocity vector v bar, and it is a vector quantity. So linear momentum, right? Okay. So we were talking about change in momentum because force is rate of change in momentum. Force is a rate of change in linear momentum. Rate of change in linear momentum. So linear momentum. We took an example yesterday. So now we will continue some cases of linear momentum. Okay. Yeah. Hi everyone. Right. So now observe these situations. Suppose you have a vector. Okay. This is a vector. This is one vector, and there is one more vector like this. Okay, one is p1 bar, the other is p2 bar. So this is vector p1 bar. Okay, p1 bar. So linear momentum. You can write simultaneously, no problem. So you don't have to, yeah. And this class is amazing because I cannot hear what you're saying. So that's actually very fine. Yeah, p1 bar and p2 bar. Okay. Now we'll do this part. Let's. So this is, I'm extending P1 just to find the angle between them. Okay, right. So this is angle between P1 bar and P2 bar, correct? हमको कभी भी एंगल होना है तो एंगल बिटवीन टू हेड्स लेते या टू टेल्स लेते. So yes, of course you have to write. This is very very important, children. You have to write. You must write. Right. So this is the direction of P1 bar, correct? This is the direction of. Oh, sorry, what happened? Yeah. This is the direction of P1 bar. P1 bar was going in this direction. ये direction में जा रहा है, ऐसा जा रहा, ऐसा जा रहा. Now it turned and angle theta. Okay, so we know this is head. ये head है ना उसका. और इसका हेड ये है, तो we cannot we have to join the heads or join the tails. So now the angle between P1 bar and P2 bar is theta. Now I am willing to find the change in momentum P2 bar minus P1 bar. So why are we finding change in momentum? Sir, because force के लिए rate of change in linear momentum है ना, force is F bar is equal to delta P bar by delta T. So we need to know delta P bar. That's why we are trying best to learn more about this P2 bar minus P1 bar. Yes, sir. So if I take P2 bar minus P1 bar and I want to find the modulus of this one delta P bar, which is what we have done yesterday also. So this is modulus of P2 bar minus P1 bar, and we all know that the modulus of P2 bar minus P1 bar is simply root of P2 square plus P1 square minus 2 P1 P2 P2 square plus P1 square minus 2 P1 P2 P1 P2 cos theta cos theta, right? Right. So this is the modulus. So now the magnitude of force will be simply delta P upon delta T. Okay. सर ये फॉर्मूला क्या याद रखना है, जरूरत नहीं है याद रखने की. आई एम जस्ट टेलिंग यू कैन हाउ टू फाइंड डेल्टा पी बार. सो डेल्टा पी मॉडुलस इज सिंपली इन दैट वे. इसका एक एग्जांपल ले लेते हैं. लेट्स ट्राई टू सॉल्व एन एग्जांपल हियर. सो लेट्स टेक एन एग्जांपल. लेट्स से देयर इज अ मोमेंटम वेक्टर which is in this direction, ऐसा जा रहा. Okay, and this is one vector and this is one more vector like this, or you can also say like this. So the initial momentum is in this direction. Initial momentum is in this direction. Okay, initial momentum is in this direction, which is P. I'm directly giving you as P. So now this is the continued direction of P, and this is angle 120 degrees. Okay, and this is again P. तो मैग्नीट्यूड में मोमेंटम चेंज नहीं हुआ, बट डायरेक्शन में चेंज हुआ. इसका मतलब चेंज हुआ. सो व्हाट इज चेंज इन मोमेंटम? फाइंड डेल्टा पी, मतलब मैग्नीट्यूड चाहिए. डू दैट. इसको ऊपर लेके जाएंगे. डू दैट एंड टेल मी द आंसर. यू कैन डू इट, आई नो. Delta P, find delta P. You can find it easily. So here what happened, the magnitude didn't change, but only direction changed. So you can find delta P in the following manner. So delta P is equal to root over. So P2 square can be written as P square. P1 square is also P square. Minus 2 P1 P2 is P square into cos 120 degrees. What is the value of cos 120 degrees? Minus 1 by 2. So this is it becomes root over P square plus P square. Cos 120 is minus 1 by 2. So it becomes plus P square. Very good. So this will give you root 3P. So what is root 3P? Change in linear magnitude of change in momentum. Root 3P is magnitude of change in linear momentum. Correct? Good morning. Yes, nice. So students are following. So we can move forward now. Okay, this was just an introduction. Now we'll take some cases. In that, the first case I would like to discuss about is rebounding of a sphere. Rebounding of a sphere. Rebounding of a sphere. Okay. So let's see. What is the concept of rebounding of a sphere? So rebounding of a sphere hai kya? Suppose you take a rigid wall. This is a wall. We're calling it as a rigid wall. Rigid matlab ekdam strong hai ye. So this is rigid wall. Okay. Basically, in physics, rigid wall is represented with something like this. It is not a mirror. Okay. It is a rigid wall. Okay. Okay. Somebody is asking me. See, I don't have to go back to the slide. You can simply pause the video and you can copy it. ये तो लाइन वैसे ही रहता ना, तो you can later also you can copy, no problem. Right. Rigid wall, okay. So this is rigid wall. All right. Right. So now I take a small sphere. Here is a small sphere. Small sphere. Observe carefully. Very, very important, children. Wait. So this ball, which we have taken, this sphere or ball, whatever, it is moving towards right. Okay, it is moving towards right with certain velocity, and I'm calling that velocity as v. I'm calling that velocity as, let's say, v1. Okay, v1 velocity के साथ जा रही है. And now I would like to take this as x-axis and this as y-axis for reference. Okay, for reference I have taken x and y-axis. So the sphere which is going with velocity v1 here, the sphere which is going with velocity v1 here, it will hit the wall and it will rebound. It will hit the wall and it will rebound. So it is hitting the wall. Wait a second. So something wrong has happened. Yeah. So it is hitting the wall and rebound matlab lag ke wapas aana. That is called rebound. Rebound. Coming back is called rebound. Okay. So when it hits the wall and rebounds, iska matlab the wall is exerting some force on it, right? The wall is exerting some force on it. Bounce back is called rebound. So let's say it will come out with a velocity v2 this time, hitting with velocity v1 and coming back with velocity v2. So rigid wall gaya, sphere जाके लग के वापस आ गया. So here we are supposed to find out the change in momentum. अपने को क्या find करना है? Change in momentum find करना है. Change in momentum. So how to find out? Change in momentum. Change in momentum. So vector you have to find change in momentum. Okay, we'll do some cases of this one. Okay. Okay, Zainab. Right. So initial, so let's say mass of this is m. Here also when comes out mass is m. So initial momentum vector can be written as mass into velocity. So m into v1, but I am writing it as I cap. ये क्या आपको okay है देख लो. The reason I am writing I cap because it is moving towards right ना. So what about final momentum vector p2 bar? It can be written as m into v2. This time I have to write minus I1 bar, minus I1 cap, because it is in the opposite direction. So I want to find out change in momentum vector p2 bar minus p1 bar. So delta p bar it is. Okay. So how do you write that? P2 is again minus mv2 I cap. फिर initial minus of initial momentum is mv1 I cap. You followed this one? So the change in momentum is, I think I can take minus m common here. Then you have v2 plus v1 into I cap. V2 plus V1 into I cap. So in this situation, if I say if the ball rebounds with same speed, if the ball rebounds with the same speed, so what do I write? Can I write V1 and V2 are same and that is equal to V? So therefore I have ये लेके जाके इसके अंदर substitute करना. Then you have delta P bar is equal to minus M into V plus V into I cap. So this will give you minus 2 mv I cap. Matlab, sir, why you got minus? Because force is applied in this direction. ये ball जब इधर आ रहा ना, the ball is coming towards right, but the wall is applying force on the ball. See, the ball is coming like this. Ball is coming like this, and it is going this way. So that means force is applied on the ball in this direction. Force is applied by the wall on the ball in this direction. जो arrow mark में लगाया ना, वो direction में apply करा, तो इसीलिए negative आ गया. That's why you got negative. Okay. So this is when both of them have same velocities. Now we'll take a situation where rigid wall is there, but the inclination is there. मतलब क्या है सर? See, same rigid wall, वही rigid wall ले रहा हूं मैं. Okay, copy, paste. Right. So now this time what happened, sir? The same ball, but this time the dinner. Right, dinner. So this time, what is happening to this one? Right. So this time the ball will hit at an angle. ये और से देखना, observe carefully because this is going to be important in terms of finding change in momentum. It is hitting this way. Now I will draw a normal here. We all know that what is a normal. We all know what is normal. Normal is nothing but a line which is perpendicular, right? So I am drawing a normal. See, this is normal. Okay, normal. N for normal. Right. So the ball is hitting the wall, making an angle theta with the normal. ये important है. किससे angle कर रहा भी important है. Making an angle. What is the angle made by the angle made with the normal? Theta. Okay, children, let me know if you are following it. So this is the initial momentum. Let's say this is with velocity v. Yes, very nice, children. So it will rebound back with same. Yeah, very good. It will rebound back with same speed. Not necessarily same, but let's say I'm assuming it is rebound back. My case ले रहा हूँ कि it is rebounding back with the same speed. Okay, same speed velocity. जब तक सोचते रहना, I'm explaining what will happen. You have to think. Okay. So yeah, so the ball has rebound. I think we can slightly make them bigger. Okay, right. थोड़ा बड़ा कर दिया. Very nice, children. Very good. So it is rebounding back. Now I want to find out the change in momentum. So what is the change in momentum in this particular case? So let's say this is, I want to call it as a case 1. Case 1 is the case where the ball hits straight and comes back with velocity v2. Case 2 is a ball hits the wall at an angle. Ball hits the wall at an angle. Okay. Now can you tell me what is the change in momentum in this case? Yeah. सर इसमें क्या करना है सर? इसमें अभी करना क्या है, कंपोनेंट्स बनाना है. Here you have to make components. अब observe carefully. Now you observe carefully. First of all, when ball was hitting this direction, if I want to make components, then I will make like this. Okay, this is normal. This is normal. Okay. तो components अगर यहाँ पे clearly समझ में नहीं आए तो it is important. That's why see, this is the velocity v. Okay, v, and this angle is theta. If that is v and this angle is theta, I think I can make two components of this velocity. One is in this direction, which is v cos theta. V cos theta. The other is in this direction. I'll change the color, right? Which is this is v sin theta. This you understood? मतलब बॉल जो आ रहा ना, एक v cos theta से ऐसा हिट कर रहा. This is v cos theta and this one is v sin theta. Okay. When it rebounds back like this, rebounding back like this, I've chosen some other color for this one. So when it rebounds back in this direction, let's say this is the velocity, same velocity se rebound ho raha, correct? Then it is coming back with this velocity here. Since this angle is also theta, it becomes v cos theta here and v sin theta here. Sir, v cos theta in right direction only. Why? Excellent question. I was expecting this. बेटा अगर ये वेक्टर है तो इसके दो कंपोनेंट्स यही होते ना. अगर वेक्टर ऐसा जा रहा तो इसके दो कंपोनेंट्स ये और ये होते. Why downwards? How can it be upwards? Look at the arrow mark. Suppose somebody is pulling you this way, it is as if they are pulling you this way plus this way. Or somebody is pushing you this way, that means they are pushing you this way and this way. Now you have a vector like this. कोई आपको ऐसा ढकल दे रहा है, vector like this. It means that is in this direction and this direction. That is why I'm saying components. It is very basic. So for this, which is rebounding, which is rebounding, ये है ना rebounding. So ऐसा rebound हो रहा है. तो इसका मतलब this is one component, this is one more component. Cool. Yes. So right. So if you observe, ये डायरेक्शन में मोमेंटम अलग से चेंज करना है और ये डायरेक्शन में मोमेंटम अलग से चेंज करना है, करेक्ट? तो because momentum is a vector quantity, so you have to find. But if you observe along y-axis, there is no change in momentum because initial भी v sin theta था, final भी v sin theta है, तो दोनों same direction में है. तो I think you can write along y-axis there is no change in momentum. Along separately you have to do along y-axis no change in momentum. No change in momentum because there is no change in velocity. But what about along x-axis? There is only change in momentum, so that you can write along x-axis there is change in momentum. तो ये अगर situation compare इससे करे तो v1 से जा रहा v2 से आ रहा तो you wrote this one v2 plus v1, right? v1 से जा रहा v2 से v1 plus v2 you have written. Here also what I do, yes, cool, yeah, I am cool, of course, yeah. So here if you observe, for this I made component, one is v sin theta, the other is v cos theta. So v cos theta is going this way. And for this rebounding, I made two components, one is v sin theta, the other is v cos theta this way. तो v sin थीटा तो कैंसिल हो गए। अब ये दिस इज द सेम सिनेरियो, v cos थीटा से अंदर जा रहा और v cos थीटा से बाहर आ रहा, तो चेंज इन मोमेंटम यहाँ पे जीरो नहीं होता क्योंकि डायरेक्शन है। So that's why along x-axis the change in momentum is px, सिर्फ x लिख रहा हूं मैं, बार भी लिख देता हूं, is minus 2mv cos theta. Correct? This live will be saved on my YouTube. You can watch as many times as you watch. And apart from this, there are many videos also. If it is helpful to you, you can watch. Some of them are in Telugu, some in English. Yeah. Yeah. Hindi also. Thode. Is it okay? So I made a small mistake here. It has to be I cap. Right. Nice. Now, minus y. You think why it is minus? Because here also you got minus. Why you got minus here? All right, children. Now we'll take a situation of a particle moving in a circular path and I want to find out the change in momentum. So here is a particle, change in momentum for a particle moving in circular path. Opposite direction, yeah. Change in momentum for a particle moving in circular path. Okay. Sir, इसमें moving in circular path with uniform speed. With uniform speed, this is not uniform velocity बच्चों, uniform velocity नहीं है। uniform velocity में सर्किल पे आप जा ही नहीं सकते। सर्किल में अगर जाना है तो यूनिफॉर्म स्पीड से जा सकते, एक ही स्पीड, नॉट यूनिफॉर्म वेलोसिटी। सो चेंज इन मोमेंटम फॉर अ पार्टिकल मूविंग इन सर्कुलर पाथ विद यूनिफॉर्म स्पीड, सेम स्पीड, हर जगह स्पीड सेम है लेकिन वेलोसिटी का जो डायरेक्शन है वो बदलते रहता। सो दिस इज द डायरेक्शन ऑफ वेलोसिटी हियर, दिस इज द डायरेक्शन ऑफ वेलोसिटी हियर, this is the direction of velocity here. Yeah, so this is the direction of velocity here. So velocity direction will keep on changing, but the magnitude of velocity remains same. So that means here momentum is changing. Okay, momentum is changing here, right? So how to find out the change in momentum? At every point on the circular motion, the particle is moving with speed v. इधर भी v है, इधर भी v है. Okay, here also the speed is v. So I want to find out the change in momentum. Actually, we have already done this one, which is change in what do you say? Change in velocity. Magnitude of change in velocity हम लोग already करे थे, but still we'll do it again. Right. So let's say this angle is theta. This angle is theta. Can anyone tell me what is the change magnitude of change in velocity? Okay. The magnitude of change in momentum is magnitude होना है ना, तो delta p can be written as, can it be written as m delta v? Can it be m delta v? And also we know that delta v can be written as 2v sin theta by 2. If you already know this one, ये कैसा करें हम लोग मालूम है, रूट ओवर v1 square plus v2 square minus 2v1 v2 cos theta. We've done this in class. So 2v sin theta by 2. So that means the magnitude of change in momentum will be m, if you have to multiply with m, then it will be 2mv sin theta by 2. These relations are actually important. Sometimes they help you in solving problems very easily. All we have to do is, yeah, good. You have to do is to just remember that things. Change in speed is 100% zero. Speed change in aura. But the velocity is changing in direction, not in magnitude. Uniform, जिसको बोलते हैं uniform circular motion. Sir, what is uniform circular motion? The motion in a circle where the particle is moving with same speed but different magnitude is also same, but the direction is only changing. Okay, ये वाला. Right. Now I would like to talk about impulse. Impulse एक बात कर लेंगे, उसके बाद remaining we'll discuss in tomorrow's class. ठीक है? Impulse. It is important to understand impulse. Impulse. What is impulse? खींच के एक थप्पड़ मारा ना, कल्ला छल्ल बोलता, उसको बोलते हैं impulse. Impulse is large force acting on a body for short interval of time. Impulse is large force acting on a body for short interval of time, for short duration of time. Impulse is large force acting on a body for short duration of time, which causes finite change in momentum. ante means momentum change होने वाला है, तो large force acting on a body for short duration of time which causes finite change in momentum. Finite change in momentum is called as impulse. Okay, right. एग्जैक्टली. तो आपको ड्यूरेशन जो है ना बहुत कम रहना चाहिए. You have to understand this one. The short duration is the underline here. बहुत कम ड्यूरेशन है ये, for short duration only. Suppose example, अरे example sir, give me some example sir. Regular life, daily life के examples क्या है? Cricket, hitting cricket ball with bat. Hitting cricket ball with bat. Hitting cricket ball with the bat. Correct? If it is longer, it is not called as impulse. सिर्फ change in momentum बोलते हैं उसको. Change in momentum and impulse are same only. You tell me the examples. Kicking a football. जो पहला जो example दिया मैं, वो भी वही है ना? Blow of hammer on a nail. Wow, Meza, you're killing it. How does finite change happen, sir? देखेंगे हम लोग. See, when this is the direction of ball which is coming, and you take a bat and hit it, the momentum, the ball direction is reversed. No change. See, both change or momentum. It is not short. Duration is short, but momentum change is not short. See, you take a bat, सचिन तेंदुलकर है या विराट कोहली जो भी है और क्रिस गेल, तो बॉल ऐसा आ रहा, बैट को लगते ही जो डायरेक्शन चेंज हुआ, मतलब मोमेंटम जबरदस्त चेंज हुआ. तो फाइनाइट चेंज इन मोमेंटम. दैट इज इफ आई ड्रॉ अ ग्राफ फॉर दिस वन, graph of this one, see, observe what happens if I draw a graph of this. So don't miss the class tomorrow. You might be tomorrow also we'll discuss about problems on impulse and all that. So every class is precious. So this is a time on x-axis, force on y-axis. So right. तो पहले तो फोर्स एक्ट नहीं करा, सडनली अरे इसको क्या हो गया. So force was not acting initially, but suddenly force acts and again it will fall down. So this is short duration. Duration has to be very less. Something like this. Large force acting. Suddenly the force rises and again it falls down. Clear? You might have also seen this in like extra edge में भी देख के रहते आप. Right? So this, yeah. Whatever it is, whatever you want to call, you can call. So this is short duration. ये भी लंबा duration हो गया. Wait, we'll cut this. No, this is perfect. If you observe the duration, where did it start? It started here. The time it ended here. So this small delta t, and you apply large force acting on it. It's called impulse. Impulse is a large force acting for a short interval of time. So this is called impulse. Change in momentum. Impulse is change in momentum. So impulse is indicated with symbol J. It is actually J bar. Okay, it is a vector quantity. So impulse is basically J bar is equal to delta P bar. So how do you calculate delta P bar, sir? Observe this one. हम लोग क्या करना है, इसको कैसा करना है देख लो. Sir, we all know that force is equal to dP by dt. Perfect. dP by dt is perfect. Thrust of a rocket is not impulse, Muhammad Wasim. So then here dP will be equal to F into dt. Now I'm integrating on both sides. So integration of dP is equal to integral f dt. Okay. So from t1 to t2. Let's say this is t1 and this is t2. And integration of dP is nothing but delta p, right? Integration of dx is a delta x. Integration of dP is delta p. So what you have got delta p here? Delta p is equal to integral f dt from t1 to t2. This is called impulse. This is actually J bar, J. Can anyone tell me what does this represent? Integral f dt. What does this integral f dt represent? क्या ये एरिया अंडर दिस ग्राफ है? लाइट रिफ्लेक्टिंग ऑन अ मिरर, हाँ वो भी इंपल्स बोल सकते, बट does it? Yeah. This is, so the final conclusion of this is it is basically representing J is nothing but area under ft graph. Heart attack, yes. Okay. How area, sir? Sir, very good question, sir. I'll be very intrigued when students ask this kind of questions, ma. Because when I say integral y dx represent area 100 times, and despite of that, when you cannot compare this with this one, really, ma, very good. When I take integration, it is area. dy by dx, slope. So force is the slope of PT graph. I can say that also. Because since f is equal to dp by dt, is it like in the form dy by dx? So force is slope of pt graph. Slope of linear momentum time graph. Okay, ma? Right, very nice. Thank you very much, children, for cooperating the class. We will meet you in tomorrow's class. Until then, take care. Enjoy your holiday. If there is any time you can write these notes, I'll check your notes tomorrow. Thank you, all of you. Jazakallah. Allah Hafiz.